Good afternoon, Doug. Do I pronounce your name correctly? I always ask this question because I'm terrified of pronouncing people's names incorrectly.
You'd be amazed how many emails I get that address me as Doe, Dough, but you nailed it.
Oh,
It's just Doug. Yeah, no H.
Doug. All right, all right. First question I always ask, and you've been briefed, so maybe you had some time to prepare. If not, that's totally fine. We're going to improvise. How would you introduce yourself? You have the choice between three keywords, three numbers, a combination of both, or anything else you'd like to say about yourself.
So I chose three numbers. They are one, two, three, because I like things that are really as simple as can be. Uh, you know, it's a beautiful little progression, and I like things that are minimal, tight, compact, and that sequence seems to fulfill those criteria.
Totally fair. In fact, you like things to be simple. I guess you also have a knack for trying to explain difficult things in as simple fashion as possible, which leads me directly to your contributions to the Dev Library project, where two of your content pieces were selected. One of them is an open source project called Pixplot, and the other one is a blog post that I think you published 2 years ago, 2.5 years ago, about encoders, and you try to explain as clearly as possible what those are. Do you want to start with a blog post on what this is about and what makes you passionate about, if people have not realized by now, I'm talking about machine learning in particular, and TensorFlow. Do you want to talk about the blog post a little bit and what this is about?
Sure. I'll just start by saying I'm grateful that you said you find my expressions pretty clear. I I spent the last 5 years at Yale University. I've been in higher education for a long time, and like teaching is pretty important to me. I love clarity of expression, and I try to express myself as clearly as possible, and really appreciate when others do as well. And a lot of my work, I really try to elucidate, some of these highfalutin concepts in machine learning or stats, just to sort of like widen the fold, if you will, bring others into the field. So I appreciate those kind words. The blog post, we can look at it if you like. I'm a very visual learner. I think a lot of people are visual learners and don't know it. So I like to look at things. But yeah, in a nutshell, the blog post is on sort of describing how an autoencoder works. We talk about the fact that an autoencoder is can be thought of in a few different ways. One way to think of autoencoders is as a dimensionality reduction algorithm. So we take some data and some, high dimensionality, like wherein each object is represented as a list of numbers, and that list is long. And we want to project each of those objects down so that each object is represented by, let's say, just two numbers. And if we do that, then we can sort of display our objects in a Cartesian plane, an old school two-dimensional plane with X and Y axes. And we can see sort of the relationships between objects by virtue of an object's position in the space. Similar objects will be positioned similarly or proximate to one another in the space. So that's one way to think of autoencoders. We talk about the fact that that is looking at that process we just described, where we're shrinking the dimensionality of our objects. That's kind of like the first half of an autoencoder. That's the encoder portion, which wants to reduce the dimensionality of input data. And then we have this really cool second half of the autoencoder, which wants to take that squeezed dimensionality, that reduced dimensionality, reduced dimensional expression of objects, and expand it back up to the original dimensionality of our inputs. So if we have images that are 32 pixels by 32 pixels, we can compress them down into just a two-digit representation. Instead of representing an image with 32 by 32 numbers, we represent it with just two numbers. And then we can expand them back up with the decoder to 32 by 32, the original data size. And basically, like with these autoencoders, we can do really fun things. The blog post walks through a sort of example in which we take the Celeb A data set. It's a popular data set of celebrity faces. And we perform this operation, shrink the images down to 2D, and then expand them back up to K dimensionality, to the original dimensionality. And we use that to create a sort of latent space. That two-dimensional representation forms this Cartesian, space in which we can, sample from an arbitrary position. We can take coordinates, x, y, and ask the decoder to expand them back up to the original dimensionality of our images. And so we can kind of like surf through this crazy space and see these evolving changes of celebrity faces.
If we roll back time, what led you in the first place to explore the field of machine learning?
My God, it's been a while. I was an English major in undergrad and in graduate school. I have a PhD in English literature. My dissertation, I was actually looking at copyright history and the ways that changes in copyright law way back in the day affected the book market. So, how does the creation of copyright law in the first place, because it was in fact, created, how does that change the geography of printing? How does the institution of fixed duration copyright, because originally copyright was like indefinite, you had a copyright forever. But then copyright became what it is today, at least in the Western world, where it has a fixed sort of shelf life and then it expires into the public domain. So how does the institution of fixed duration copyright influence the book market? And how does the rise of fair use law influence the book market? In any event, I had this huge collection of like 500,000 books, everything published essentially before 1800 in the Western, in the English Anglo tradition. And I wanted to sort of mine this huge collection of data to look at these patterns, like do book prices change after the rise of fixed duration copyright law, for instance? And so, that was like one massive project that inspired a lot of work. In fact, the Pixplot, library that we'll discuss in a second uses some computer vision to analyze image collections. And part of that, was sort of hand in hand with my doctoral research, which wanted to look at plagiarism. So, like one of the questions I asked in my dissertation is like, when fair use law becomes instituted, when it becomes legal to kind of copy others with certain parameters, do people copy more readily? Once it becomes legal to copy images from other texts, like are people copying images? And we can answer that question with computer vision. So essentially, stepping back a little bit, like I come from a background essentially in history and in historical traditions, historical patterns, and I've seen machine learning and programming generally as ways to ask new questions in historical contexts. And there's a whole field of us. We're called digital humanists. It's a really sort of exciting field. Yale University, where I've been for the last 5 years, has a fantastic digital humanities program, digital humanities lab, in which researchers are asking questions like this and using fun machine learning platforms like TensorFlow to answer those questions.
What's the biggest challenge for you to come from this English literature and history background to delve into the field of machine learning? What would you say what was the biggest challenge?
Well, they didn't teach multivariable calculus in my graduate program. So I had to, a lot of the sort of finer points of machine learning, the math at the end of the day, I needed to teach myself all of that. And so, one of the things that I find so amazing about a library like TensorFlow is the fact that you don't have to do all the math. Like you don't have to, compute the derivatives and backpropagate by hand. You can kind of use this elegant API to accomplish some of this work. And I really love that. But for a while, until I was sort of graduated to Keras and TensorFlow, I was doing a lot of this by hand in NumPy and actually computing out the math. And it was a slog, to say the least.
So let's talk about your use of TensorFlow. You've mentioned, and we talked very briefly about Pixplot, which is a combination of TensorFlow and WebGL, and it allows to visualize large image collections in a very interactive web environment. And you can actually play. I'll put the link in the description. It's going to be on YouTube. And you can play with two examples that you have on your GitHub page, which is also cross-posted on Dev Library. Do you want to talk a little bit about the genesis of this project and anything you'd like to share about it?
So The Pixplot library had a sort of evolution, and I've prepared a sort of truncated version of that, just because it could be of interest to sort of see how this idea graduated. We started in Yale's Digital Humanities Lab with a project called Neural Neighbors, and the idea here was, given a collection of images, can we find patterns in those images? Can we find images, that are similar to a given image, for example? So we have some images here from the Meserve Kuhnhardt collection. This is a collection of photographs largely from the 19th century that Yale recently acquired. And after the university acquired these, some curators were preparing to sort of, identify all this really rich metadata to describe these images. But they have a backlog, of course, and they kind of came to the lab and said, can you help us start to make early sense of what's in this collection that we've just acquired? And so Neural Neighbors was our initial attempt to answer this question. And the idea here was, we can take these images, and for each image in a collection, we can identify the k nearest neighbors, the k is just an integer, 10, let's say, the 10 images that are most similar to a given image. So here we have a building, and we can see in the sort of top row here a series of other buildings to which our selected image is similar. Another building, more buildings, lots of windows in these buildings. And now we've got a fine gentleman and a cadre of other fine gentlemen and a lady with, so we can sort of, move through this collection and identify some tropes, if you will, or like patterns within the collection. And we thought this is interesting and fun. This is going back several years now. But eventually, we kind of started to run up against limitations here, or we started to ask bigger questions. Like, instead of just looking at the pictures that are similar to this gentleman here, like, what would it be like to look at the entire collection all at once? And in order to sort of start pursuing that, we needed a more performant rendering layer. Here we're just using sort of HTML, DOM elements, but we needed to display lots of images all at once. And so we took the same sort of brains behind this operation, TensorFlow, which allows us to extract a sort of vector representation of each image. We took those same brains and we took those vectors and we just compressed the dimensionality of those vectors down to 2D, just as we were discussing earlier in the case of autoencoders. But for Pixplot, we decided to use a different dimensionality reduction technique called UMAP, and that brought us to a setup kind of like this. This is the first instantiation of Pixplot, or the first sort of release of Pixplot. This is the very alpha, and in fact, it's still linked in the GitHub. But the idea here was we take the whole collection, sort of shoot it down into 2D, and then we let you sort of move through it and look at the images in the collection, wherein we expect images with similar content to be sort of positioned close by one another. So we just saw some ladies over here. We could sort of zoom in down here and we'll see some, gentlemen with very sort of white ghost-like backgrounds. There's a cluster of boxers. These are my favorites. Look at these guys. They're great. They all stand with that great pose. So this was our attempt to sort of generalize neural neighbors, if you will, and look at all of the images in the collection at once. And once we got this far, we started showing it to others, and we started to get some feature requests. Curators, those who work with large image collections all over the world, started asking, like, could we add more curatorial affordances? So, eventually we moved on to provide some like hooks, whereby, or some user affordances, whereby you can kind of like lasso some points. I'll lasso these guys over here and sort of drill in on just the images in that area of the space. You can also sort of look at the same distribution, but in a different geometrical layout. So we'll take that 2D UMAP and sort of like stretch it out into this canvas here that's more rectilinear. And so it's just sort of evolved from that early genesis and neural neighbors through, to where it is today.
Anything that surprised you, whether in terms of, and it can be both either negative or positive, by the way, something maybe in terms of speed, in terms of the documentation needed to be able to find what you were looking for, either missing or actually convenient. This is really an innocent question that I'm asking.
Sure, sure. So when I got started with machine learning and neural networks, I was, following the lectures of Andrew Ng. I was reading Andrei Karpathy's lecture notes and trying to code not trying, actually coding neural networks by hand in JavaScript, like Andre, and eventually in NumPy, but doing everything manually, back propagating all those error gradients by hand. And what blew me away was just how easy Keras and TensorFlow make this work. I mean, you don't have to spend all of your time slamming away on the math. You can if you want to, but if you're looking to build prototypes and ship really quickly and iterate, in response to user feedback, these APIs are like absolutely perfect for moving quickly. So I was just pleasantly surprised by how easy TensorFlow and Keras make this work.
What's the worst piece of advice you've heard in the field of machine learning?
Uh, the worst piece of advice, this isn't just in machine learning, but I guess never quit would be the worst piece of advice. I feel like you should quit all the time, or know when to redirect and sort of translate your course to a better, more promising direction. That's that's
What signals would you be
yeah.
using to know when to redirect, to know when to stop? It's actually a question that is often asked by startup founders when they know that they need to be careful with their time and at some point maybe redirect their efforts. But the statement stays true for anybody undertaking any kind of project. Which signals do you read, or which metrics would you use? What would you do to know when it's time to stop or redirect your efforts?
It's a huge question.
You
I
started it.
mean,
I'm blaming you.
I did for sure. My intuition is when things stop flowing naturally, when things become difficult, like haltingly difficult, I think it can sometimes make sense to pursue the path of least resistance. Like um, growth is natural. When something works for others, when you're building, solutions that help others, there's a sort of natural momentum and natural energy and sort of discussion that follows from that. It's when things become like halting, when it's difficult to sort of get feedback and converse with others about software you're building or products you're building. That's when sometimes you need to take a step back and think about sort of how to reimagine, the next steps forward.
That's fair. Let me ask you a question about open source. I know I'm jumping topics. I'm looking at the clock at the same time and want to respect your time. What made you release Pixplot as an open source project? You didn't have to, and I'm always positively surprised and pleased when I see so many interesting projects. To the point that in this case, when I read up the details of on the GitHub page, I want to play with my own data set and see what I can do. So I started following your instructions, again, very clearly explained. So what leads you to release things in an open source way?
Well, in the case of Pixplot, I was working for Yale University, and we had a sort of charge in our lab to make as much of our sort of contributions to the software world as possible open and publicly accessible, in no commercial terms. So uh, it was a huge privilege spending time with the lab and building software that others sometimes found useful. I would say, even more generally in my personal life, I really like building things that other people find useful and when possible, contributing back to the open source world because I think so many of us learn from open source. I mean, we come up looking at other people's examples and getting excited by tools and projects others are building. And many of those are sort of non-commercial. They're just open and free to the world. And it's great to give back when we can.
What is something that excites you going forward? Something you want to play with? Any new version of TensorFlow? Again, we can't talk about confidential stuff that you may be aware of. I don't know how, but who knows? But anything that you're looking forward to? on new hardware, on new software?
Well,
What is something that you're keen to play with?
yeah, I've been obsessed with making audio, generating sort of pseudo electronic. It's really like chiptune music. Like sounds like a Game Boy or like an old 8-bit Nintendo. Making these crazy little audio files with TensorFlow. You can train like a really simple, two-layer LSTM network and create some like really fun audio samples. If I can share my screen one more time, I'll play you just one such example. I mean, so I've got another blog post, first post in a long time, but here we're training some very simple algorithms and generating some chiptune music.
Should we be expecting the next music hits coming from you? Do I have the privilege of knowing that information?
I wouldn't go that far. I mean, the band Anamanaguchi has been doing this way better than I can hope to, and they're still a pretty small indie band, but just it's super fun. I find it, exciting, and I think music and video are kind of, fields that need additional work in machine learning. So I'm
Do you
excited
play an
to spend
instrument
more time in
yourself?
the audio domain. I do. Yeah, I've got a guitar right here. I've spent my whole life in bands, indie bands, punk bands, folk bands, all sorts of things. Love it.
Very nice. Any final words for developers?
God, I would say make things that people find useful. Go forth, never stop experimenting.
Excellent. That wraps up our interview. Thank you very much, Doug.